Hello viewers, welcome to Serica's Math Made Simple. So I want us to look at type of numbers today. Now, the reason why I'm doing this video on the types of numbers is because I realized that most students, even advanced students, grew up without really having proper knowledge on the types of numbers. Some advanced level students, they can't tell you what a real number is. They don't really know what an integer is. If you ask what's a natural number, they can't tell you what the natural number is. And in math, sometimes when we solve, we are instructed to leave our answers as real numbers. So sometimes some students solve and maybe the answer comes out in the form of a natural log, maybe something like lane 2. And they start asking themselves, is this a natural number? Is this a real number? Is this an integer? What kind of a number is this? Why? Because of gaps that were created in their understanding of the concepts right from the very beginning, from elementary math. They were not properly taught. And that is why I am making this video. So make sure you watch with keen attention and you learn. Okay? So we're looking at types. Now, link 2 is a real number, just so you know. We are looking at types of numbers. Now, the first type of numbers I want to talk about is the natural numbers. So let's write the natural numbers. Natural numbers. Now, so what are natural numbers? What are natural numbers? Now, natural numbers are whole numbers, okay? And they are counting numbers. They are the numbers we use in our day-to-day life. We use to quantify. We use to measure. For example, if you have a number of cookies right now, and a friend asks you, how many cookies have you got? You're not going to say you have 0.5 cookies or 4.2 cookies or the square root of 5 cookies or why? Because those are not the numbers, the normal numbers we use in counting. The normal numbers we use in counting in our day-to-day life is what we call the natural numbers. Okay, and the natural numbers have the symbol n, usually written like this. So this set is a set of natural numbers beginning with 0. Okay, so 0 is a natural number. Now I explain something about this. So 0, 1, 2, 3, 4, and so on. So it continues. Now, natural numbers are made up of only positive numbers. Remember, I said they are counting numbers. Now you may be wondering, but there is 0, there is 0 a counting number. Do we use 0 in counting? Now, because of that, when we're talking about counting numbers, positive counting numbers, which are natural numbers, without 0, we say they belong to a different set, which is Tn, but this time around the n is written with a star. Okay, and the presence of this star tells you that is without the inclusion of 0. So you start from 1, 1, 2, 3, 4, and so on, and so on. So these are natural numbers. So things to note about natural numbers. Natural numbers are positive numbers. They are always positive numbers. Secondly, natural numbers are whole numbers. Okay? And third, 0 can be a natural number. But when we are talking about natural numbers as counting numbers without 0, we are talking about the set n star, which starts from 1, 2, and so on. Is this clear? Next type of number I would like us to talk about are the integers. Okay? So let's look at the integers. Integers. So what are integers? Integers So what are integers on the board? Can you see integers on the board? What are integers? Now, integers are also whole numbers. Okay? Integers are whole numbers which can be both positive and negative. Unlike natural numbers which are only positive numbers, integers on the other hand is both positive and negative, and it also includes 0. So 0 is an integer. All right. So when we're talking about an integer consists of all negative numbers, negative whole numbers, including 0, and also all positive whole numbers. Now, integers are denoted by the set z, usually written like this. So this is a set of integers, and they can be both negative. Let's say I start from, can be negative, -2, -1, 0, 1, 2, and so on and so on. So this is how the set of integers looks like. Okay, so the numbers that fall in the set or in the category or the type of numbers called the integers, these are the things you must note about the numbers integers. An integer can be positive or negative. It can be both negative or positive. That's true. The set of integer is with the inclusion of 0. It includes 0. So 0 is an integer. Okay, that's true. And then finally, integers are whole numbers. So an integer cannot be expressed as a fraction or a decimal. Integers are always whole numbers. I hope that makes a lot of sense. I hope that helps you. All right. Next set of numbers I want us to look at are the rational numbers. Rational numbers. So what are rational numbers? Rational numbers. Rational numbers. Rational numbers. Now let me write this here. Rational numbers. So what are rational numbers? What are rational numbers? Now we are now moving into something into a new idea. Okay, now a rational number is a number that can be written in the form a on b, where this a and this b are both integers. Okay, and then b can be any other number, any integer except 0. So rational numbers are numbers that can be written in this form. So they are like fractions. Okay, and that is why I call fractions numbers. When I teach fractions, I always tell my students fractions are numbers, but not just any type of number. They are not the natural counting numbers that we know. They are special type of numbers that can be written in the form a on b, with b being every integer with except 0, so that you have a clear picture of what rational numbers are. So rational numbers are fractions. Okay, so they can be written in the form a on b, and this a and this b are integers. So we are having integers coming up as by this division, and they give a number that is a known whole number, because rational numbers are not whole numbers. So here are the important things to note about rational numbers. A rational number can be both negative and positive. Okay, So a rational number can be both negative and positive, but they are not whole numbers. Rational numbers, this is a big but. They are not complete numbers. When we say they are not complete numbers, it means we are saying they are not whole numbers. Okay? They can be fractions, okay, or decimals. All right? So those are rational numbers. And what makes them this way is because a rational number must be expressed in the form A on B. They always exist at this form as a fraction. And that's why we call them rational numbers. Rational numbers are represented or denoted by the symbol cure, special type of cure like this. So this is a set of rational numbers, okay? And cure can be both negative, comma, and positive. Is that okay? So someone can ask, is 0 a rational number? Yes. 0 is a rational number because if I write 0 on 1, that equals to 0. Notice the only problem is we cannot have the denominator to be 0. Because if you have 0 on 0, this makes no sense in mathematics. When you have the denominator of a fraction being 0, it makes everything undefined. It doesn't exist in math. Okay? So, but when the numerator is defined to be 0 and the denominator is defined to be any other integer, the whole of that fraction or rational number boils down to 0. So that's why it's safe to say 0 is a rational number. Is that okay? The only thing you must note about rational numbers is that rational numbers are not whole numbers. They are not complete numbers. They are like fractions. They are incomplete numbers. They are not whole numbers. Like integers and natural numbers, which are whole numbers. Rational numbers, on the other hand, are non-whole numbers. Is that okay? Beautiful. All right. So let's move to the next set of numbers, which are the irrational numbers. So what kind of numbers are irrational? What do we call irrational numbers? Irrational numbers. So here I'll just take off this, just take rational off, and then I'll write above it on the line irrational numbers. So what are irrational numbers? Now, irrational numbers are numbers that cannot be written in the form A on B. Okay, and this A and this B are still integers. They still belong to the set of Z. But now we are talking about irrational numbers. Irrational numbers are a special type of numbers that cannot be expressed. Now you can say they are rational because they can exist in the form of decimals, but not like fractions. Okay, but not like rational numbers. Okay, they are irrational. Now examples of irrational numbers, we have things like root 2, the constant pi. These are the type of numbers we call irrational numbers. Now, whenever an irrational number is expressed in the decimal form, there are two things to note. If you go to your calculator right now, if you punch root 2 on your calculator, it gives you something like 1.4129. Now, a pattern you will observe is it never ends. The decimal never ends. It always continues, and then it never repeats itself. It always continues with different numbers, a long pattern with different numbers. The decimal never repeats itself. We cannot have 0.333333 because that is a fraction and that is a rational number. But if it's called an irrational number, the pattern cannot repeat itself like we have 0.333. You have different figures and then it will be repetitive. It will be long. Okay. You see, the sequence doesn't end. Different numbers just keep, that's just how it goes. Do you get that? So these are the type of numbers we call irrational numbers. Now, these irrational numbers can both be negative and positive. Now, just like irrational numbers, they are not whole numbers. So the similarity between rational numbers and irrational numbers is that they are both non-whole numbers. Okay? They are incomplete numbers. They are different from integers and natural numbers because natural numbers and integers are all whole numbers. We don't deal with anything rational there. But when we come to rational and irrational numbers, they are not whole numbers. They are called non-whole numbers. They are incomplete and they can be negative as well as they can be positive. Is that okay? Beautiful. Now the next set of numbers I want us to look at are the real numbers. The real numbers. So what are the real numbers? What are real numbers? What are real numbers? Real numbers. Right. Real numbers. So real numbers. Are now, what are real numbers? When we talk about real numbers includes all natural numbers, all integers, all rational numbers, and all irrational numbers. All of those. So every number on the number line is what we call a real number. So if a number is a real number, it means that number. Now, in a math language, I can write natural numbers n for what real numbers are. Natural numbers are real numbers. Okay. Integers are real numbers. Okay. Rational numbers are also real numbers. Irrational numbers are also real numbers. Real numbers are denoted. The set of real numbers is denoted by the letter arrow, a funny type of arrow written like that. So whenever you find this arrow anywhere, it represents the set of real numbers. So real numbers can be both negative and positive. It can be zero. Okay. So now in a nutshell, in math, in set language, we can write n to be a subset of z. Okay. Why? Because n are positive whole numbers. Those are natural numbers. And in a set of integers, we have all positive whole numbers, since integers themselves are both positive and negative whole numbers. And this is a subset of q, and all of this a subset of r. So natural numbers are in r, integers are in r, rational numbers are in r, even irrational numbers are also in r. Okay, so the set of rational numbers consists of all the set of natural numbers, integers, rational numbers, and irrational numbers. All of those numbers, that's every number on the number line, is a real number. I hope this helped you. Now, the last set of numbers I'd like us to look at today are the set of complex numbers. Now, let's look at the complex numbers. Complex numbers. Complex what are complex numbers? Now, those of you who are doing so what are complex numbers? Now, complex numbers, let me underline this. Complex numbers are a special type of numbers. Okay? Now, these ones are not real numbers. They don't exist on the normal XY plane that we know. They have their own plane called the Argand plane. All right. Now, a complex number is a special type of number in advanced mathematics that exists in the form, or that can be written in the form. If you call a number a complex number, that means that number exists in the form a plus bi. Okay. Now, complex numbers are made up of two parts. This is the first part, A, called the real part, and this is the second part, B, called the imaginary part. Now, B is called the imaginary part because it is attached to this I here. Now, according to complex numbers, the value for this I is equals to the square root of -1. And you know, it's a very, very special case when we have a -1 inside the square root. Since that cannot be expressed, it is called I. So it is studied in a special field with numbers called complex numbers. So complex numbers can be negative, it can be positive. Now, all real numbers are complex numbers with their imaginary part 0. So you can call all real numbers, for example, I can have a complex number as 1 plus 2i. Now, if I say 5 is a complex number, that's true because this is just 5 real parts plus 0i imaginary part, which is still 5. And that's a complex number. Now, complex numbers are denoted by the symbol C, like that. Now, so if you want to express a mathematical or a set language of all of these types of numbers we've looked at today, we will notice that N, let me write this with another ink, is a subset of Z, being a subset of Z is a subset of Q, okay, and this is a subset of what? R, which is itself also a subset of C, like that. So this relationship is very correct. So N for natural numbers, Z for integers, Q for rational numbers, and irrational numbers are supposed to be here too, and then C for R for real numbers, and finally C for complex numbers. So that's why I said all real numbers can be complex numbers whose imaginary part is 0. Thanks for watching. Now, if this video helped you, make sure you share with your friends so that they can learn as well. See you in our next class.